Hello bachcho, welcome to JEENious classes. Today is our 14th class on functions and this class will be the continuation part of my previous lecture. In this class we are going to discuss about additional problems on types of functions from very basic level to advanced level. So stay tuned to us till the end of the video. And if you are new to my channel, don't forget to subscribe and press the bell icon so that you get notified about all the new videos I upload in this channel. If you really like my class, don't forget to hit the like button and share it with your friends. And don't forget to comment me. So let's begin the class. बच्चों इस क्वेश्चन को देखो, if f is from 0 to infinity to 0 to infinity and fx is x by x plus 1, then they have asked for find the type of the function. Type of the function मतलब ये function 1 1 है या many 1 है, ये पहले तुम्हें determine करना है. Second करना है ये onto है या into है. Is it clear? Okay, so let us say the function which is given is fx is x by x plus 1. मुझे ये चेक करना है ये फंक्शन 1 1 है या many 1 है. So for that what I'm doing, हम थोड़ा सा इसका simplification करते हैं. So I can write this thing as 1 by x plus 1. और इस फंक्शन को अगर हम differentiate करें, so we are getting 1 by x plus 1 का whole square. Now for all x belongs to 0 से infinity. For all x belongs to 0 से infinity, look it very carefully. F dash x is always greater than 0. It means that fx is a strictly increasing function. और fx अगर strictly increasing function है, इसका मतलब ये function क्या बना? Injective function और 1 1 function. Right? अभी मुझे चेक करना है ये सर्जेक्टिव है कि नहीं, मतलब ये ऑनटू है या इनटू है. ओके, नाउ यहां पर द कोडोमेन इज 0 टू इंफिनिटी. द कोडोमेन इज 0 टू इंफिनिटी. टू प्रूव दैट इट इज एन ऑनटू फंक्शन वी हैव टू शो दैट इट्स रेंज एंड कोडोमेन दे आर इक्वल. सो मतलब ये क्या हुआ, ये जो फंक्शन fx है इसका मुझे रेंज निकालना है, इसका रेंज निकालना है. चलो बच्चों करते हैं. Y is nothing but x by x plus 1. If I cross multiply, we are getting. So y by 1 minus y is equals to x. बच्चों x क्या है? x is greater than equals to 0. इसका मतलब ये हुआ y by 1 minus y is greater than equals to 0 implies y by y minus 1 is less than equals to 0. मतलब माइनस कॉमन लेके हम साइन चेंज कर दिया. अभी बच्चों फ्रॉम द नंबर लाइन वी कैन से दैट आवर क्रिटिकल पॉइंट्स आर 0 and 1 और प्लस माइनस प्लस, सो y विल कम हियर. सो द रेंज ऑफ दिस फंक्शन इज क्लोज 0 to open 1. Now we can easily see that here the codomain is from 0 to infinity. But the range is 0 to 1. That is 0 to 1 is a subset of 0 to infinity. इसका मतलब ये हुआ ये फंक्शन का रेंज और कोडोमेन इक्वल नहीं हुआ. इसका मतलब दिस फंक्शन इज एन इनटू फंक्शन. राइट? मतलब ये फंक्शन का टाइप क्या होगा? दिस इज 1 1 into. Is it clear to all of you? Okay, let us take another problem. In this problem, they have said that f is from minus 1 to 1 to b. Be a function defined by fx is tan inverse 2x by 1 minus x square. If fx is bijective, bijective का मतलब fx is 1 1 as well as onto, then find b. Okay, so actually they have asked for to find out the range of this function because onto function कब होगा? जब कोडोमेन ऑफ द फंक्शन इज इक्वल्स टू इट्स रेंज. और इसका कोडोमेन जो दिया हुआ है इस फंक्शन का दैट इज b. अगर रेंज हम निकाल दे एंड इफ इट इज एन ऑन टू फंक्शन एज इट हैज बीन सेड हियर, सो योर बी विल बी नथिंग बट द रेंज ऑफ दिस फंक्शन. सो मेरा प्राइम टास्क क्या है? टू फाइंड आउट द रेंज ऑफ दिस फंक्शन, राइट? ओके, चलो, x बिलोंग्स टू -1 से 1. लेट अस अज्यूम x इज इक्वल्स टू tan थीटा. मतलब क्या हुआ? थीटा इज tan इनवर्स x. Now, as x belongs to -1 to 1, that implies your theta belongs to -pi/4 से pi/4. मतलब 2 theta will belong to -pi/2 से pi/2, right? Okay, now what about our function? The function changes to tan inverse to tan theta by 1 minus tan square theta. So that gives us tan inverse tan 2 theta. जिसका मतलब क्या हुआ? 2 theta, right? Why? Because we know that y equals to tan inverse tan x can be written as x when x belongs to -pi/2 से pi/2. Now यहां पर tan inverse tan 2 theta को हम लोग 2 theta लिखा. क्यों? क्योंकि 2 theta belongs to -pi/2 से pi/2. Is it clear? Therefore, fx is 2 tan inverse of x. Now we all know that tan inverse of x in the given domain, it lies between -pi/4 से pi/4. So 2 tan inverse x will lie between -pi/2 से pi/2. Is it clear to all of you? Therefore, the range, which in turn in this question is the set B, which is nothing but your -pi/2 to pi/2. Is it clear to all of you? Absolutely. Now let us move for the next problem. Which of the function is a 1-1 function? The function that has been given here for the first one is that f is from R to R and the function defined as e to the power signum of x plus e to the power x square. So first of all, I have to redefine this function. So fx becomes e to the power 1 plus e to the power x square when x is greater than 0. That is the definition of signum function. When x is greater than 0, signum of x becomes 1. Signum of x becomes -1 when x is less than 0. And this equals to, when x is equals to 0, signum of x is 0. So it is e to the power 0 plus e to the power 0. That gives us 2. Is it clear? Therefore, our redefined function is fx equals to e to the power x square plus e, x greater than 0, e to the power x square plus e to the power -1 when x is less than 0, and this is equals to 2 when x is equals to 0. Is it clear? Now बच्चों देखो, when x is greater than 0, your f dash x is coming to 2x e to the power x square. As x is greater than 0, f dash x is also greater than 0. Means your fx is an increasing function when x is greater than 0. Now when x is less than 0, your f dash x is coming to again 2x into e to the power x square, but x is less than 0. If x is less than 0, f dash x is also less than 0, means the function is a decreasing function. मतलब यहां पर डोमेन क्या है? x belongs to any real value. So in the given domain, the function is somewhere increasing and in somewhere decreasing. Therefore, the function is a many one function. Is it clear to all of you? Okay, let us take another problem. Check whether this function is an 1-1 or not. Now again, I have to redefine the function. Here fx equals to e to the power x square plus x when x is greater than 0. This will be equals to e to the power x square minus x when x is less than 0, and this one will be e to the power 0, that is 1, when x is equals to 0, right? Now, if I go for f dash x, for the first one, when x is greater than 0, so what we are getting? We are getting 2x plus 1, right? Now, बच्चों देखो, when x is greater than 0, when x is greater than 0, then guaranteed e to the power x square plus x. This part is always positive. And when x is greater than 0, 2x plus 1, this is also positive. So the product is also greater than 0. Therefore, fx is an increasing function when x is greater than 0. Clear? और देखो बच्चों, f dash x when x is less than 0, क्या हो रहा है बच्चों? It is coming like 2x minus 1. अभी देखो, e to the power x square minus x when x is less than 0, this is positive, right? But when x is less than 0, when x is less than 0, 2x minus 1 is negative. Is it clear? So if it is negative, the product will also be negative. Therefore, f dash x is less than 0 when x is less than 0 means your fx is a decreasing function. Again, in the given domain, from -1 से infinity. देखो बच्चों, यहां पर x is less than 0 लिया है, मतलब in the given domain, it is greater than -1. Right? But still, when x is lying between -1 and 0, again, 2x minus 1 is less than 0. Therefore, the function fx in the given domain -1 to infinity, somewhere it is an increasing function and somewhere it is a decreasing function. Means your fx is a many one function. Is it clear? Okay, let me take another one. See this one? fx is root over ln cos of sin x. Now to define the function ln cos of sin x, it has to be greater than or equals to 0. It means cos of sin x is greater than equals to e to the power 0, which is equals to 1. लेकिन बच्चों cos थीटा कभी भी 1 से ज्यादा होता नहीं, मतलब cos of sin x, from this equation we can say the only possible value is cos of sin x is equals to 1, right? बच्चों देखो, cos of sin x equals to 1 ये तब possible है when sin x is 0, and sin x is 0 possible है when x equals to n times pi, where n belongs to any integer. Is it clear? मतलब when x belongs to integer multiple of pi, then this equation, this function is defined, right? अभी देखो बच्चों, what will be the value of the function fx? जब cos of sin x is 1, cos of sin x is 1, then ln of 1, log 1 base e is 0. मतलब fx का वैल्यू is always coming to 0, right? मतलब इसका डोमेन क्या हुआ? फंक्शन का डोमेन हुआ n pi, where n belongs to z, और इसका रेंज कितना हुआ? रेंज इज ऑलवेज 0, राइट? अगर इसका ग्राफ हम ड्रॉ करें, देखो, अगर हम इसका ग्राफ ड्रॉ करें, मतलब डोमेन इज n पाई, n का जगह में 0 लेंगे तो क्या होगा? इट विल बी 0 दिस पॉइंट, and the value of y, the corresponding value of fx is 0, so it is on the x-axis. When n is 1, that is pi. When n is 2 pi, n is 2, then the domain will be 2 pi, 3 pi, and so on. Minus pi, minus 2 pi, and so on. देखो बच्चों, यहां पर for 1 y, the y is 0. For that value 0, it is mapped with infinite number of values in set A. Yes or no? Because your set A now consists of minus pi, 0, pi, 2 pi, 3 pi, and so on. And the range is only 0. And all these elements are mapped with 0, isn't it so? All the elements are mapped with 0. It means what? It means that this function is a many one function, right? Not only from this mapping, you can see it by the graph also that for y equals to 0, we are getting lot of x's like pi, 2 pi, 3 pi. These are all the values of x for which your y becomes 0. Is it clear to all of you? So it is also a many one function. Okay, let me take another one. See this. The function f is defined from 3, 4 to 4, 6. And the function defined like this. Mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3 plus mod of x minus 4. Now we have to check whether this function is a 1, 1 or many one function, right? बच्चों हम already ये चीज in my previous classes where I have discussed about the range and domain, I have shown you the shortcut method of solving this kind, the graphing this kind of functions that I've already shown you. If you have not seen my previous video, link has been given in the description box. Go and check it. So here बच्चों देखो your x belongs to 3 to 4. Now when x belongs to 3 to 4, we can easily write our function fx as. Is it clear? So we are having, it is coming, y is coming like 2x minus 2. This is the function when x is lying between 3 and 4. Now when x is 3, then your y is coming to, that is 4. And when x is 4, we are getting y as 6, right? मतलब ये function का graph in the given domain कैसे होगा? The function will look like this. At x equals to 3, the value of the function is 4, and at the value x equals to 4, the value of the function is 6. Therefore, the function is only a straight line whose slope is positive between 3 to 4, right? And the range is also from 4 to 6. Therefore, this is the exact graph of this function in the given domain 3 to 4 and in the given range 4 to 6, right? We can easily see from this graph itself that if we go for horizontal line test, you will find every time within this domain, every time the horizontal line is intersecting the function at only one point. That is, for one y belongs to 4 to 6, we are always getting one x lying from 3 to 4. Therefore, this function is very much a 1, 1 function. Is it clear to all of you? The previous three options was not a 1, 1 function. They were many one function, but this function guaranteed is a 1, 1 function. Is it clear to all of you? Okay, let us move for the next problem. In this question, they have said if the function defined from R to A, R is the real value and A is an unknown set, and the function defined by this one is surjection. मतलब ये function is an onto function and we have to find out the set A. That is, we actually have to find out the range of this function because here the codomain is A. Now, if we can find out, since it's a surjection, and if we find out the range, it means the range and codomain, they will be same. Therefore, your set A will be nothing but the range of this function. Now, to find out the range of this function, we will first redefine this function. When x is greater than 0, the function fx comes to like this. So we can write this thing as e to the power x minus e to the power minus x divided by 2 times e to the power x. So we are having e to the power 2x minus 1 by 2 times e to the power 2x. This is when x is greater than 0, right? Now, when x is less than 0, in that case, your fx comes to e to the power x minus e to the power x divided by e to the power x plus e to the power minus x. That gives us 0. Therefore, when x is greater than 0, fx is e to the power 2x minus 1 over 2x. And fx is 0 when x is less than 0. Is it clear? And when x is equals to 0, then the function comes to 1 minus 1 divided by 2. So that gives us 0 again. Fx is 1 minus 1 by e to the power 2x when x is greater than 0. So f dash x is basically coming to 2 by e to the power 2x. And when x is greater than 0, we can easily see that your f dash x is greater than 0. It means that fx is an increasing function when x is greater than 0. Therefore, the graph of this function will look like when x is less than 0, fx is 0. That is, we are talking about the x-axis, that is this portion. When x is 0, fx is 0, that is, the origin is included. And when x is greater than 0, the function is an increasing one. So the graph will look something like this. Is it clear? Now we can easily see that the domain for this function is x belongs to any real value. That's okay. But the range of this function is y belongs to close 0 till infinity, right? Therefore, the range for this function eventually, which is the codomain A, is nothing but 0 to infinity. Is it clear to all of you? Is this problem clear to all of you? Okay. See this problem. If f is from R to R is given by fx equals to 2x plus alpha square when x is greater than equals to 2, and alpha x by 2 plus 10 when x is less than 2. This is the function how they have defined. Now they have said that fx is an onto function. Then we have to find out the range for alpha, right? This kind of problems are always better if we solve it graphically. Because the moment we can draw the graph of the given function, we can easily check the conditions for which the function will be an onto one. Correct? But जो देखो fx equals to 2x plus alpha square है जब x is greater than equals to 2. Now it is very clear that this function is a linear function, or linear function ka graph is always a straight line, and we don't know anything about alpha. Alpha can be greater than 0, alpha can be less than 0, whatever it may be. So we don't know about alpha, but whatever may be the value of alpha, alpha square is always positive, and 2x plus alpha square, this indicates that the straight line has a positive slope. So it is an increasing straight line. So how the graph will look like? Let us say this point is our x equals to 2. So the graph will look something like this. From here, it is an increasing straight line. So it will be like this. Is it clear or not? This is your x equals to 2. Okay. Now, the second part of this function is alpha x by 2 plus 10 when x is less than 2. अभी बच्चों यहाँ पर दो केस मुझे कंसीडर करना है because I don't know what is alpha. अगर मानो alpha is less than 0, then this is again, let me just tell you before that, this is again the equation of a straight line because this function is again a linear one. So it is a straight line, and when alpha is less than 0, it will have a negative slope. And the moment it will have a negative slope, the the straight line will look either it has a negative slope. So the line can be like this. Okay. The line can be from here, it will move. Or else the line can be somewhere here, it will be like this. Is it clear? When alpha is less than 0, because the line has a negative slope. Now we have to check whether this assumption is correct or not. Now बच्चों देखो यहां पर fx equals to alpha x by 2 plus 10 जब alpha is less than 0 है, if I consider that the straight line will be like this, but it is an onto function. What do you mean by onto function? For all y belong to your set B, if a function is defined from A to B, then for all y's, all elements in set B must have a pre-image in set A. Then only we call that function an onto function, otherwise not. But if we consider the second part of this function is the straight line like this, in this case, suppose this point, when x is approaching towards 2 from the negative direction, the value is, say, something over here, right? The value of the function. बच्चों अभी देखो, any value of y which is less than this value, will not get any value of the function. I mean, any value which is less than this point for the values of y, you are not going to get any x. Because if I draw a line which is parallel to the x-axis below this point, again I'm mentioning, below this point, you are not going to get any x. What does it mean? It means that there will be some y. In this case, there will be some y which will not have any pre-image in set A, that is in the set of the domain. Therefore, it will no more remain a onto function. So, this form of the graph is rejected because this is not possible. Is it possible if the straight line looks like this? Again, with the same argument, this is also not possible. At the same time, this is also not possible. Is it clear or not? Because any value below this point for y, you are not going to get any x. Means it will no more remain an onto function. Is it clear? So, alpha is less than 0. Practically, it is not possible. Okay? So, एक decision हमने ले लिया कि alpha has to be greater than 0. It cannot be less than 0. So, in that case, how the graph will look like, let us just draw it. Let me erase this portion. Abhi bachcho, if alpha is greater than 0, then it will have a positive slope. I mean, this line will have a positive slope. So, the graph can be, the straight line can be like this. So, the line can look like this, or it can look like this. Why I have given this thing as solid? Because it may so happen that when x is approaching towards 2 from the negative direction, it may so happen that this value, the function is approaching towards the value when x is equals to 2. It may so happen. Or else, the line can be like this. Now observe it very carefully that if I choose this line, is it true? Can the straight line look like this? Answer is no. Why it is so? Because observe very carefully, if I choose this line, then between these two values, there are a lot of y's. Because here the codomain is any real value. So there are a lot of y's in between this point and this point where, this point and this point where there will be no x available. Is it clear or not? Because if I draw any line which is parallel to the x-axis, for that y lying between these 2 points, you are not going to get any x because this line is not intersecting the curve at any point. Therefore, the function will be no more an onto function. Is it clear? Therefore, this method is not possible. This form of the graph is not possible. Is it? This form is possible? Yes, it is possible. Why? Because here, for all y belongs to real value, that is for all the elements of the codomain, you are going to get 1x. That is, the line, the horizontal line, will always intersect the curve at one point. Means for all y's lying in set B, it has its pre-image in the domain set. Is it clear? So this line is possible. Is this line possible? Yes, it is also possible. Because in this case also, let me just erase this portion. Now, if we consider this line, observe it carefully. For all y belongs to any real value. For all y belongs to any real value. That is, if you take any real value y, it is going to get, because you see, this line is extending, right? So for all y belongs to any real value, you are getting at least one value of x. That is, for all elements of set B, it has its pre-image in set A. Are you getting the point? Therefore, we can say that these are the two conditions where the function can be, if it is an onto function, then the curve will look like either like this or like this. Okay? And the condition is that your alpha is greater than 0. I hope you have understood this. Okay, now from here, can we say one thing that, see, this curve is what? This curve is 2x plus alpha squared. Now, when x is 2, then the value is 4 plus alpha squared. That is, this point is basically, the value of fx is 4 plus alpha squared. Now, when x is approaching towards 2 from the negative direction, it is h tends to 0. We can write this thing as 2 minus h. And for that case, the function is this. So, the value of the function is approaching towards. So, it is coming like what? If I put h is 0, so we are getting alpha plus 10. So, this point, the value of y or the value of the function at this point is alpha plus 10. Now, just now I have explained that your line, that is this curve, this straight line, can be of this form or it can be of this form. In both the cases, what we can write, that your alpha plus 10, this is greater than or equals to 4 plus alpha squared. Is it clear? Means the value of y, this one, can be equals to this one when this line has been assumed like this line. Okay, if this line takes the form this, then your 4 plus alpha square will be equals to alpha plus 10. Or else your alpha plus 10 will be always greater than 4 plus alpha square. Is it clear to all of you? Absolutely. So from here we are getting alpha square minus alpha minus 6 is less than equals to 0. So if I factorize, we are going to have alpha minus 3 alpha plus 2 is less than equals to 0. And therefore, from the number line, we can say alpha is greater than equals to minus 2, less than equals to 3. But we have already assumed, we have already said that alpha is greater than 0. Therefore, the range for alpha is alpha will be greater than 0, but less than or equals to 3. Is it clear to all of you? Therefore, the range is open 0, close 3. But so if we can draw the graph of the given function, it will be very easy for us to deal this type of questions, right? So let us move for the next problem. In this question, they have said that if a function f is defined from a to b is given by this one, is bijection. Bijection means it is 1, 1 as well as onto. So we have to find out what is set A and set B. That is, in one word, they have said to find out its domain and range. Because as the function is a bijective function, hence its codomain B will be equals to its range. So it is required to find out the domain of the function A and its range B. That's it. So we are having 3 to the power fx plus 2 to the power minus x is 4. So from here we can write so fx is basically log base 3 4 minus 2 to the power minus x. Now to find out the domain, first of all we have to find out for which the function is defined. We have to find out the values of x for which the function is defined. In this case, the function will be defined when 4 minus 2 to the power minus x is greater than 0. So that implies, so we are having 2 to the power minus x is less than 2 squared. So that implies minus x is less than 2. So x is greater than minus 2. Is it clear? Therefore, the domain for this function is from minus 2 to infinity. Is it clear to all of you? Now we have to find out the range of this function. Now, as x is tending towards minus 2, as x is tending towards minus 2, your fx is log base 3 4 minus 2 to the power minus x. As x is tending towards minus 2, observe it very carefully, your fx is tending towards minus infinity. Am I correct? Because as x is tending towards minus 2, 2 to the power minus x is tending towards 4. And 4 minus 4, it is tending towards 0. And log 0 is tending towards minus infinity. And as x is tending towards positive infinity, we are getting fx is tending towards, look it very carefully, if x tends towards infinity, 2 to the power minus x is tending towards 0. And as 2 to the power minus x is tending towards 0, it means that fx is tending towards log 4 base 3. Therefore, its range will be from minus infinity to log 4 base 3. And eventually, since it's a bijective function, this will be our set B. So our set A, which is our domain, is from minus 2 to infinity, and the range for this function will be from minus infinity to log 4 base 3. That's it. Is it clear to all of you? Okay, let us take another problem. But you see this question. If the function fx is ax cubed plus bx squared plus cx plus d sin x, then find the condition that fx is a 1-1 function. Condition मतलब क्या है? Condition मतलब है you have to find out a relation between the constants. In this case, it is a, b, c and d. That is what is called the condition. Okay, now fx is a 1-1 function always. याद रखो ये fx is a 1-1 function always. तो फिर क्या करेंगे? कैलकुलस मेथड से हम लोग कैसे चेक करते थे whether a function is a 1-1 or not, if it is strictly increasing or strictly decreasing. लेकिन ये function strictly increasing होगा या strictly decreasing होगा, that we don't know. Why? Because we don't have any control over the constants a, b, c and d. Check it. F dash x is how much? It is 3ax squared 2bx plus c plus d cos x. This is the derivative of the given function. Now this function can be strictly increasing, that is f dash x is greater than 0, or it can be strictly decreasing, that is f dash x is less than 0, because we don't know whether the curve will be increasing or decreasing. So both the cases we have to consider to find out the condition. Is it clear? Okay, now let me take the first one. When the given f dash x, the derived f dash x is greater than 0. That is, the function fx is strictly increasing. In that case only, the function will be a 1-1 or injective. So, in this case, remember a very, very important conclusion, that is, when you find that your a plus fx is greater than 0 for all x belongs to real value. If this expression a plus fx is always greater than 0 for all x belongs to real value, then that implies that your a has to be greater than minus f, minimum value of the function. Okay, your a will be greater than minus of the minimum value of the function fx. And if a plus fx is less than 0 for all x belongs to real value, this is very important thing. If it is not for all x belongs to real value, then this condition will not hold. In that case, you will say that a is less than minus f max of x. That is, your a will be less than the negative of the value of maximum value of fx. Is it clear? So in this case, if I consider this thing as my a and this thing as my, let us say, gx. So in this case, what we are having, a plus gx is greater than 0. Now, बच्चों एक चीज देखो, what is the domain of this function? The domain is x belongs to any real value. So a plus gx will be always greater than 0 for all x belongs to real value to make it an increasing function. Then only it will be a 1-1 function, right? So in this case, we will write that a is greater than minus g of minimum value of x. Now, your gx is d cos x. But what is the minimum value of gx? The minimum value will be minus d. And what will be the maximum value of gx? It will be d. Okay? Because we all know that cos x lies between minus 1 and 1. Okay. So in this case, your a, which is 3ax squared plus 2bx plus c, this is greater than minus of g min x, which is nothing but your minus d. So it will be like this. So 3ax squared plus 2bx plus c is greater than d. इसका मतलब क्या हुआ? 3ax squared plus 2bx plus c minus d is greater than 0 for all x belongs to real value. For all x belongs to real value. मतलब a quadratic expression is always greater than 0 for all x belongs to real value. It is possible only when a is greater than 0 and discriminant is less than 0. Are you with me? This all I have completed in quadratic equation classes. So, what is the discriminant over here? The discriminant is b squared minus 4ac. This is less than 0. So that implies what? B square minus 3ac minus d is less than 0. So what we got from here is b square is less than 3ac minus d. Is it clear to all of you? Absolutely. This when I have assumed that f dash x is an increasing function. But it may so happen that it is a decreasing function. In that case also the function will be 1, 1 if it is strictly decreasing. Okay, so in that case what will happen? This f dash x, that is, this will be less than 0 for all x belongs to real value. In this case also, if we consider this is as a and this is our gx, so our a plus gx is less than 0 for all x belongs to real value. Now we all know that a plus fx when less than 0 for all x belongs to real value, your a is less than minus of f max x. So in this case, plus c, this will be less than minus of d. Because the maximum value of gx, which is d cos x, is nothing but d. Is it clear? So our expression is coming something like this. C plus d, which is less than 0. This is for all x belongs to real value. Is it clear to all of you? बच्चों अभी बोलो, a quadratic expression is always less than 0. always less than 0. For all x belongs to real value. ये कब होगा? It will happen when your a is less than 0 and the discriminant is also less than 0. In that case, for all x belongs to real value, the expression will be always less than 0. So in this case, our discriminant is again, we will get the same discriminant like this. It will be 4b square minus 4 into 3 into a c minus d. This is our discriminant, which is less than 0 in this case. So in this case also we are getting b square is less than 3 times a c minus d. Is it clear? I'm sorry बच्चों, यहाँ पर c minus d नहीं होगा, यहाँ पर c plus d होगा, because यहाँ पर c plus d था और यहाँ पर मेरा c minus d था. c minus d था, इसके लिए आंसर में c minus d आया. But in this case, it is c plus d, so we are going to have c plus d. Therefore, from the second one, we are getting that b square is less than, again, 3ac plus d. Is it clear? In both these cases, the given function will be always a 1-1 function in the given domain, which is, in this case, is any real value. Okay? So, combinedly, we can write this thing as b square is less than 3a c minus modulus of d. C minus modulus of d. So that is the condition for which the function is a 1-1 function. Is it clear to all of you? Absolutely. Okay, let us move for the next problem. बच्चों देखो ये question, f is from capital X to capital Y be a function defined by fx equals to a sine x plus pi by 4 plus b cos x plus c, and if fx is a bijective, then find x and capital Y. इसका मतलब क्या हुआ? Bijective मतलब the function is 1-1 as well as onto. मतलब in one word they are saying you have to find out the domain for this function as well as you have to find out the codomain, which will become in this case our range. Right? Means indirectly they are saying find out the domain and the range for this function so that the function fx becomes bijective. Is it clear? Okay. Now, बच्चों अगर fx को हम थोड़ा सा सिंप्लीफाई करें तो क्या लिखेंगे? साइन ऑफ x प्लस पाई बाई 4, इसको हम साइन a प्लस b का फॉर्मूला में ब्रेक कर रहे हैं. सो इट विल गिव यू साइन x cos पाई बाई 4 plus cos x sin pi by 4, and b cos x is there, c is there. So it will become a sin x root to bahar le liya plus cos x plus b cos x plus c. Is it clear? Because sin pi by 4 and cos pi by 4 both are 1 by root 2. So if I open the bracket, we are getting a by root 2 plus b cos x plus c. Okay. Now let us assume a by root 2 is r cos theta and a by root 2 plus b is r sin theta. Okay. Therefore, if we divide both sides, we are going to have tan theta as a plus root 2b divided by a. And if we square both sides and add, we are going to have r square equals to a by root 2 whole square plus a by root 2 plus b ka whole square. So if I open it, a square by 2, a square by 2 plus 2 times a by root 2b plus b square. So we are having a square plus root 2ab plus b square. So that implies your r is under root a square plus root 2ab plus b square. Correct? Therefore, our expression fx becomes, from this one, your expression fx becomes r times cos theta sin x plus r times sin theta cos x plus c. So if I take r common, this is coming like sin x plus theta plus c. Okay, अगर ये फंक्शन बाइजेक्टिव है, then we all know that x plus r theta, in this case x plus theta, देखो बच्चों, y is equals to अगर sin x था, तो अगर ये बाइजेक्टिव फंक्शन है, मतलब इसका इनवर्स अगर एग्जिस्ट करेगा, मतलब हम लोग क्या लेते थे कि x lies between minus pi by 2 to pi by 2, then only the inverse will exist or the function will be a bijective one. Is it clear? Can you remember it? I have all done this in inverse trigonometric functions. So in this case, अगर इसको bijective होना है, इसका मतलब x plus theta को मुझे लाई कराना पड़ेगा from minus pi by 2 से pi by 2 के अंदर. इसका मतलब क्या हुआ? Your x is coming like, okay, that implies your x belongs to closed minus pi by 2 minus theta, pi by 2 minus theta. Is it clear? Is it clear to all of you? So this is actually the domain for this function to make it a bijective one. Okay, so this is nothing but your capital X. And we all know that your theta I have already calculated here. Your tan theta is a plus root 2b by a. So your theta will be tan inverse of this thing. Is it clear? So that is the domain. Now we have to go for its range. The codomain is y. Since it is bijective, so your codomain will be equals to its range. But यहाँ से देखो, sine of x plus theta, this always lies between minus 1 and 1. Therefore, r sine x plus theta, this will lie between minus r and r. And if we add plus c in both sides, we are getting less than equals to r plus c. And this is nothing but our expression. So our expression is lying between minus r plus c and r plus c. Therefore, its range will be range, which in turn, in this case, your y set will be what? It will be closed interval minus r plus c and r plus c. Is it clear? And what is r? R is this expression. Okay. So these are the range and domain for this function fx, for which this function will be a bijective one. Have you understood this problem? It's a very, very interesting sum. So let's end our class here. Thank you for watching. I hope you have enjoyed my class. If you have really liked my class, don't forget to hit the like button and share it with your friends. Don't forget me to comment. So your one comment inspires me to create a video of this kind in the future. We are having our learning app in Google Play Store. Link has been given in the description box. You can download it and you can ask me any sort of question there, because I used to come twice a week live in the app. Till then, take care and goodbye and stay tuned to us.